Hello everyone, today we'll be doing Cambridge IGCSE Additional Mathematics Syllabus Code 0606 May-June 2025 Series Paper 1 Variant 3. So before we start the video, you can attempt the questions on your own and pause the video to try on your own before you review the answers to yourself. Right, let's crack on. So paper 1, again, the new syllabus, there's no calculator involved here. So let's try not to use the calculator as well. First question, given you a cubic graph and they want you to find, or they give you some unknowns and they want you to find those unknowns. So obviously we know that we can see the roots here. They're giving us the graph so that we can see the roots. So we have three roots. First root is at x equals to -2, so that will give us a factor of x plus 2, right? Then equals to 0. And next one, the root will be at 1 over 2, -1 over 2. So x equals to -1 over 2. That gives us a factor of x, or 2x plus 1 equals to 0. Lastly, here we have a factor, or root of 1. So x equals to 1, and the factor will be x minus 1 equals to 0, right? So a will be definitely the 2x, the one with 2x, that will be a. So a equals to 1. And B or C, it's a bit ambiguous, but you can give either one of those answers. So B is 2 and then C is 1, or -1, I'll say. Right, so this will be the three answers, the three unknowns. Okay, next. Use the graph to find the values of x for which y is greater than or equal to 2. Okay, so let me just sketch that equation. Y equals to 2, right? Y equals to 2 will be this line, the red line. Obviously, if you have ruler in the exam, use your ruler. So okay, let's read the graph. Where does it intersect? It will intersect here, here, and also here. Okay, so remember you can only read to the closest half square. So if it's closer to the line rather than the middle, so I will take it as on the line itself. So here will be -1.7, here will be -1, and here will be 1.2. Right, so we have our three answers, but then again, okay, what does the question want is the inequality where y is greater than or equal to 2. So we need to check which part of the graph is above this line. So it will be this part and also this part. And so the x values lie between this one and also greater than this value. Right, so we have our two inequalities here. X satisfies this inequality when it's between 1.7 and -1, while here x must be greater than or equal to 1.2. Okay, next. Find the values of which k for the equation has two equal roots. Okay, two equal roots meaning the discriminant b squared minus 4ac is equals to 0, because if I open the formula sheet, remember the quadratic equation. If this equals to 0, there's only one root, or basically the roots will be the same. So it will only be b over 2a, because this square root has no value if it's 0 lah. Okay, so what in this situation our b is 4k. So b squared minus 4, a is 1, c is 3 plus k. This is the constant term where no x. Okay, end up you should have a quadratic in terms of k, and you should be able to factorize this. Okay, after you factorize, you should be able to get two answers. K is -3 over 4 and k is 1. Okay, this polynomial, given where there is one unknown and given a factor with a remainder. Okay, that's not a factor. So you want to write Px as a product of linear factors. Alright, first thing, let's find the unknown first. So we know with the factor theorem, if x plus 2, so then x equals to -2, we need to evaluate it at this point. So p of -2, then the remainder is 84. So we substitute the values in. We should be able to get -31 for a. And so our equation, we can write it properly now. And now we want to find the linear factor. So uh obviously for the first factor you need to guess. You need to guess, and what values you should guess is the factors of 30, right? The factors of the constant term. So it can be 30, it can be 31, it can be 10, 3, so on and so forth. 5, 6. Okay, so we need to try until we get a remainder of 0. So let's try P5. Okay, and just so happens we tried the first try for x equals to 5, we get a 0. So therefore we know that x minus 5 is a factor, and we can proceed to do your long division or synthetic division, up to you what you want to do, but I will do the long division way. Okay, so after your long division, you found out is the quadratic factor is x squared 5x minus 6. So now we want to factorize again this quadratic. Okay, so yeah, after factorization we get our three linear factors, and that will be the px solved. Question 4. Solve this log equation for x greater than 0. Okay, so first of all we can see LG, that is log base 10, and we have a log 10 base x here. So let's try to simplify things by um, changing this base to log 10. So if you forget the change of base formula, if I want to change this form into log base c, so I will take the log base c of b and log base c of a. So this will be the log change base formula. So in this case, I want to change to log 10. So this log 10 base x, I'll first put LG, then the 10 goes on top, then LG x goes on the bottom. Then we rewrite the rest of this equation. Okay, remember that this log rule also. Yeah, remember this log rule. Log base a of a, this just gives you 1. Right, so in this case also, log 10 base 10, this is just 1. Then I can simplify this to just be 2 log x. Further, here this one, remember this log rule also. If I have a power inside the log, I can take it out to the front. So n log a. In this case, I want to reverse this. The 2, I want to bring it to the top of the x. So LG x squared, then the rest of it. And now 2 log minus, right? Let's say log a minus log b. You can combine both of the log and you divide both of the thing. So here I will just divide it. Now 2 log on log on both sides. I raise both sides to the power of 10 and they will cancel. I'll be left with a quadratic, or yeah, after I simplify this, it will be a quadratic. And we need to solve this quadratic. X equals 2 and x equals to 4. But not finished, because remember in the question it states the domain x must be greater than 0. So this case where x is negative 2, we have to reject this answer. Okay, because why? The log base, obviously it cannot be a negative. Here in the question there is a log base of x, so that one cannot be a negative, so it has to be bigger than 0. Okay, next is a circle question. Given a circle C with this equation, find the equation of tangent C to the point 11,4 and give your answer in this form. Okay, so I think don't sketch that, but if you want to sketch, here the center is 5, 12, the radius is 10. Okay, this 10 square, right? And we want to find the equation of tangent to C at point 11,4. So here is 10, 5. I mean, so it's 5, 12, 11, 4 should be somewhere here. Let's say 11, 4, I use red. Let's say 11, 4 is somewhere here. So we want to find the tangent, equation of tangent, right? And what do you recall from your circle or circle theorems? A tangent will always be perpendicular to the radius. So first, let's find the gradient of the radius, and then we find the perpendicular or normal gradient. So for the gradient, that's the change of y of change of x, change of y per change of x. So 12 minus 4, and then 5 minus 11. F 8 over 6. Is it 8 over negative 8 over 6? 4 over 3. Negative 4 over 3. So our m tangent, or the perpendicular gradient, will be 3 over 4. Okay, and we want to find this line equation. So we use this point 11 for y equals to 3 over 4x plus c. Or okay, maybe it's more easier to if you use this equation. Y minus y1 equals to m x minus x1. Then we through 11 4. Okay. Okay, perhaps I simplify this further. Sorry, a, b, and c are integers. Okay, integers. So I need to multiply everything by 4. Okay, 3x minus 4y, and then this one becomes 17. Yep, so okay, this one is my final answer. Show that C and circle with this equation does not intersect. Okay, so if I sketch this, I just roughly sketch that. Circle with this equation, center at 0, 0, and radius of 2, right? Okay, radius of 2. And then this circle, show that they do not intersect. It would be at somewhere 5, 12. Somewhere here, radius of 10. Okay, 5, 12. So how to show they don't intersect? We need to show that the distance between the two radius is greater than the r1 plus r2. The two radius add together must be smaller than the distance. Otherwise, if the two radius is bigger, then they will definitely touch. Okay, so first let's find the distance between the two circles or the two centers. Okay, the distance is definitely using the Pythagoras theorem, right? We know here is 0, 0 already. So maybe I use another color. The x, it will be 5. The y, that will be 12. So to find the hypotenuse, we can use the Pythagoras, okay, the Pythagoras theorem. 12 squared plus 5 squared, that will give 13. And then also the two radius r1 plus r2 is square root of 4, and also square root of 100, that will be 12. So as long as you show it's less than 13, therefore they do not intersect. Okay, that's all you need to show. Okay, going next. Find the x-coordinates of the point of intersection of the following curves. So yeah, we need to do the equate these both equations. For ln x, 5 3 over ln x squared. Okay, so this x square, the square is inside the ln, so I can bring it forward. So the 2, I will bring it out as a constant, like that. Now, to get rid of this on the denominator, I will multiply the whole equation on both sides by ln x, like that. So this becomes ln x squared, 5 ln x, 3 over 2. Okay, be careful here. Some students tend to make the mistake. They think this square, they can bring forward, just like what we did just now, right? But no, because this square indicates the ln x. This square is the same as ln x multiplied by ln x. It's not the same as ln of x squared. Okay, it's not the same. So we cannot pull the 2 outside. Instead, we need to treat this as a quadratic equation in terms of ln x. Okay, given after factorization, you should be able to get two cases for ln x. Then they want answers in exact form, so we just need to raise both sides to the power of e. Okay, remember, ln is just a log base of e. Right, next. In this question, all lengths are in centimeters, all angles are in radians. Given that the area of AOB, okay, so this triangle only is 9 cm squared. Find the value of sine theta. Okay, it's convenient that they give us the area of triangle so that we can directly use this formula. Half AB sine theta equals to area of triangle. Right, in this case, AB is the sides that are surrounding the angle. And we know that AO and OB, those are both the radius, right? These are both radius. So they are just the same thing. So half AB, that will be 6 squared, and sine theta equals to 9. And after simplify sine theta, we can find to be 1 over 2. And part B is given that the exact area of the shaded region is 15 pi minus 9. So find the exact length of arc AB. Alright, so this shaded area is this much. And they want us to find the arc length. Okay, we know the what's it called? We know the triangle area. So if we take the whole the whole sector area, which is half r squared theta equals to the or minus the triangle, sorry. You have the whole sector area minus the triangle, which is 9. They will equal to 15 pi minus 9. Okay, r squared we know that, r we know that is 6, so 6 squared theta, and the 9's cancel, and end up with 5 over 6 pi. Now we want to find the arc length. Arc length, the formula, if you recall, is r theta. Theta is in radian, and r is 6 times 5 over 6 pi. So we just left with 5 pi. The unit is what? Cm. KCM. Question 8. Given this curve and the two coordinates, two x coordinates, we want to find. Okay, first we want to find the y coordinates. Okay, so y at point A, ya, we just substitute in the value of the x coordinate. So okay, after substituting the values, you should be able to get ya, that is 5 over 2, yb, that is 1. Now we want to show that the area of the shaded region, okay, which is this one, in this form. Okay, so probably what you want to do is find the whole area of this trapezium. Then we take away the area that's under the curve itself. So this is area of trapezium, and this is the area of under the curve. So for under the curve, we need to use the integration, but for trapezium, we can just do the average of both sides multiplied by the height. Right, so that's why we found A and B. So first of all, let's find the area of trapezium. Okay, so we know that the height is just 2 minus 1, and then here we need to take the average of these two side lengths. So that's why the half of these two added together. So 7 over 4. Okay. Next, we want to find the area under the curve. So we need to integrate. Integrate from what limits? From 1 to 2. Okay, 1 to 2 of this equation. So before we do the integration, let's do some simplification for the algebra part. Here, this x over x, we can split this fraction actually. So x over x, they just give us 1, and then we have plus 2 over x. So this is give us a simple or simpler integration. 3 over x plus 1, that gives us 3 ln x plus 1. Negative 1 integrate just gives us negative x. And then 2 over x, that just gives us 2 ln x. So there's no arbitrary constant since this is a definite integral. So to solve, I just need to substitute the values in. The top limit goes first. Alright, up to this point, we just have to simplify the natural logs. And if you recall, natural log of 1, there's just 0, so we just ignore it. And we try and collect the terms. So ln 3, there's just ln 3. It's being negative 1. And we have a negative ln 2. And yeah, I want to try and combine the two logs. So this 3, I'll move it up to the 3 power 3. ln 3 power 3. And 2, 1. So the difference of two logs, again, I will make it into one log and multiply or divide them, minus 1. Okay. What else? Okay, so now I just need to I need to just subtract the area. So the area of the trapezium minus the area of the curve. So shaded area of trapezium is what? 7 over 4 minus this part. Yep, so this will be our final answer. And A will be 3 and B is 27. Function f is defined by a quadratic. Okay, it's a quadratic with a negative coefficient on the x squared term. So it's a frowning face, okay, this shape. And given the domain of x from 0 to 3, write it in the form or the completing the square form. Okay, let's do that. First, for completing the square, I'll make sure that I'll take out the first, what's it called, the coefficient of the x squared term. So like this, and also that will affect the x coefficient also, but the constant term I will just leave it. And now we want to find what type of square will give us these two terms. So we just look at the second or the coefficient of the x and we divide that by 2. So x minus 2.25 square, that will just give us this one, 4.5x 2.25 squared. Right, this is the identity. So to isolate x squared minus 4.5 give us up to this point, then I will go and replace here into my function. Okay, after replacing, I can expand this bracket and we get this expression. So A will be 0.125 and B is negative 2 and C is negative 2.25. So okay, good. Question 2. Hence determine whether or not inverse f exists. So let's recall on what defines or what requirement does a function need to fulfill for the inverse to exist, is that it needs to be one-to-one, right? Only one-to-one functions have an inverse. So how do we determine if it's one-to-one? Is we need to check whether a quadratic at its turning point, because if there is, or if the turning point is included in the domain, what happens is for each value of y, there will be two different possible values of x. So that will be a many-to-one function, we call it. Okay, for two different values of x, or for two different value of input, there will be the same output, many-to-one. So to how to say, to restrict it to be a one-to-one function, what they actually do sometimes to make it to have an inverse, they will cut it down the symmetry point or the turning point. So in this case, our turning point, it will be, right, turning point or stationary point is what, 2.25 and 0.125. Okay, and we look at the x coordinate, which is included in the domain. So therefore, obviously, it doesn't exist already. So turning point, how do you conclude this is that turning point is included in domain. Then hence is not restricted as a one-to-one function. Right? Therefore, no inverse exists. Okay, so that's how the conclusion you should do. Function g is defined by this natural log function, and on the axis sketch. Okay, we want to sketch this. Okay, what and the values of the intercepts with the coordinate axis and the equation of any asymptote. So the asymptote will have occur at when this is 0, right? So asymptote will be at x equals to 5/2. And then also, let's talk about the shape of a graph. We know that the normal ln graph, you have an asymptote at x equals to 0, and you have this type of shape. But then now is a ln of a negative x. Right? What does that look like? For if you have a negative in the input, it will just flip. It will flip it on the x-axis. So that's what the negative does. And then we have also the asymptote part. So asymptote part, we need to draw the asymptote at 5/2 and then sketch from there. So first, let's draw the asymptote. 5/2. Okay, x equals to 5/2. And now we draw, okay, and then also the domain. Okay, start from 0. So we restrict from 0. So let's try and evaluate at 0 what's the y value. So at g0, it will just be 3 ln of 5. Okay, so we start at 3 ln 5. Then we just draw roughly the shape. And we try not to touch the asymptote as much as possible. Okay, so here label, okay, it's not really horizontal at this point, but better. So here is 3 ln 5. And what's the x-intercept? We also need to find. So we equate when y equals to 0. So 3 ln 5 is 2x is equals to 0. 5/2x equals to e power 0. X equals to 2. So here should be, okay, the x-intercept should be 2. Okay, yeah. Find the expression for inverse g. Okay, we know that if y equals to gx, so g inverse x or g inverse y will be equals to x. So that's we swap the variables, or we find the what we find back the original variable. So let y equals to the function, and then we find back the x. We find back the input. Yep, we got this expression, and remember to present it in g inverse x equals to this expression, and that will have your final marks there. It's supposed to be x, don't present it as y. Okay, so this will be the inverse, and now we want to find the domain and range of g inverse. Okay, so the domain of an inverse will be the range of the original function, and the range of the inverse will be the domain of the original function. So we know the domain of the original function, so we just write the range first. Range is the domain, right? Range of the inverse is the domain of the original. So range of G inverse is 0, 0 inclusive, G inverse, and 2.5 non-inclusive. Okay, 5/2. Okay, next what we have is the domain. So we want to find the range of this graph. What we can see here is it starts as 3 ln 5 and it only goes downwards. So, and this will go downward to negative infinity, right? So it will just be going less than 3 ln 5, and that will be the domain. Okay, domain, it will be x is less than or equal to 3 ln 5. Okay, why we include 3 ln 5? Because we include 0. Okay, so that's the reason. Okay, question 10. Okay, a vector question. So first, given that AB and AC having this type of ratio, so here is 1 and then here is 3. So here will be 2 lah. Okay. OA is A unit vector and OB is a B unit vector, and find OC in terms of A and B. Simplify your answer. Alright, so OB. Okay, let's find AB first, because to find OC we can do OB, or sorry, OA plus AC. And we know that from this one, AC will be equal to 3AB. So let's find AB. Okay, AB, from A, how do we get to B? We can just go backwards of A. There will be a negative A if we go backwards, and then we go forward B. So it will be a B minus A. That will be AB, right? AB equals to B minus A. So OA we know that is A. Just write that as that, and then 3B minus A. So our OC will be 3B minus 2A. Okay, part B, line OA is extended to C such that OA and AD has this ratio. Okay, let me just try and sketch this out very briefly. Then here got 2, here got 7. And point E lies on the line CD. Okay, CD. So there's a point E such that OE is a scalar multiple of B. Oh, okay. So from B going forward, and you intersect here. Okay, why we know this? OE is a scalar multiple of B, meaning this scalar multiple follow the same direction as the vector B. So it just makes this line longer. Right, so this whole thing, or OE, maybe I use red. This one is a lambda of B. Okay, it's a multiple of B. Okay, so now what we want to find, or aim is to find lambda. Okay. Okay, so let's try and find the expression of OE first that we can deal with. Alright, so AD or OD. Okay, to go to E. Okay, we can go from OD. Can you go O to D, then D to E? Okay, so let me just write it down. OE, OD plus DE. And okay, so DE we don't know what that is, but no matter, because again it's in the same direction as CD, but it's just a scalar multiple. So we can just take, or let's say we assign it another unknown. So something like DE is just a scalar multiple lambda is used already, so let's use another letter, gamma. Okay, we use gamma. DE is a scalar multiple gamma of DC. Okay, so we want to find DC now. DC, we can go from D to O and then O to C. Okay, we know OC, that we know, but DO we don't know. Okay, let me write it down also. Plus OC. OC we know, but DO we don't know. So DO we have to, we can use this ratio. So here is A, and that's 2, so and here is 7, so here will be, okay, maybe we can simplify this ratio. Divide by 2, that's 1, divide by 2, that's 3.5. So here is 3.5A, and D back to O, that will be negative 4.5A. Okay, negative 4.5A. So DO we know that's negative 4.5A, and OC we also know is 3B minus 2A. Okay, now we have an expression for DE, and OD we also know. Okay, OD we know now is 4.5A. So I think we can straight away solve this for OE. And we are also, we are given in the question that want to find that the lambda. So this is equal to lambda B, and we also set this equals to lambda B. And now we expand our equation in terms of A and B. Okay, now we have expanded, we collect the A and B terms, and we try and compare it. On the left hand side of the equation, there is no A term because the coefficient of the A term, there is 0. Right, so what we can do is we can equate them together. So the 0 and the 4.5 minus 6.5, we can equate them. So 4.5 minus 6.5, gamma is 0. Gamma is 9 over 13. Okay, it's a weird number. But anyway, let's proceed. And for the B component, we can just we also equate them. Lambda will be 3 of gamma, which is 9 over 13. So 27 over 13 is our final answer for lambda. Right, question 11, a kinematics question. We are given the two displacement equations for 0 to 3 and 3 to k of a particle. And we are given also that from 3 to k, the velocity is positive and the acceleration is negative. Okay, let's keep that in mind first. So we want to sketch the graph? Velocity time graph. And the maximum velocity occurs when t is 2. Okay. Alright, so okay, let's recall first. We have the displacement equations. How do we get the velocity equation from a displacement equation? Okay, displacement to velocity to acceleration, we differentiate the time derivative, right? We take the time derivative, and going backwards, we integrate with respect to time. So let's take the time derivative. Okay, for the first 3 seconds, the velocity will be 1 plus 12t minus 3t squared. Just a simple differentiation. For 3 to k seconds, the velocity will be 12 minus 2 over 3t. Okay, that's it. Okay, now we want to sketch this. Okay, we know that the first 3 seconds is a quadratic with a negative t square coefficient. So it will look something like this. Frowning face. Okay, and the maximum occurs at t equals to 2. Then it starts where the velocity is 1, because that's the constant term here. So here is 1. Okay, these are all just characteristic of the quadratic graph that you should know. And next, you want to sketch. Okay, so let's say here is 3 lah. Here is 3. From 3 to k, it's just a linear graph with a negative gradient. But we know that from the question, it says the velocity is positive. So your graph should not go into the negative axis. It will just supposed to go, or it stays above until k lah. And please use a ruler for the linear line so that it's more obvious for your examiner. Okay, what else am I missing? Maybe we can even sketch what this number is supposed to be. This will be 10. It cannot be 10, right? Okay, theoretically it's supposed to be 10, but I sketched this a bit. Maybe let's fix that. Okay, so fix it a bit. So it starts at 1, and then it's a quadratic curve, goes up and back down, and it meets the line at 10, and the maximum occurs at 2. Okay, so that's about it. A bit more accurate here. Okay, part B, now we know that the total distance is 57 meters. Given that t is 3, given that when t is 3, the distance and displacement of p from O are equal, find the value of k. Okay, we have both equations, so let's just do the calculation. It's just about calculation, I suppose. We want to find, okay, the total distance is 57. So yeah, the first 3 seconds we can do this one, s3 minus s0, okay, with the first equation. So that will be 3 minus or plus 6t squared. In the first 3 seconds, we can calculate that it traveled 30 meters. Now for the k seconds, from 3 to k seconds, how are we supposed to calculate? So we take the s, evaluate it at k minus s3. We know s3, there's 30 already, so that simplifies for us, but sk, we just need to substitute into this equation. So we have 12k. Okay, so total distance, we just have to add this both together and equate it to 57. Okay, after simplification, you should be able to get a quadratic equation in terms of k, which should be factorizable. And you're able to get two values of k, 30 or 6. But how do we choose this one? It depends, or we look at the question, what information is given us. The velocity is positive at k. Okay, at k the velocity is positive. So if you substitute, let's say what you substitute, the answer's 6 or 30, right? Okay, so we can try v evaluated at 6. What's the v equation? That will give us a negative 8 answer. So therefore we reject this one based on the basis of the question saying that the velocity should be positive at k. So k will be 6 only. Final question, the normal to a curve at the point x equals to 2 has this equation, find the values of a and b. So basic calculus type of question. First, let's try and find the y coordinate. Okay, at x equals to 2, so y equals to, we know our coordinate is this. And let's take the derivative so that we can find the gradient. To find the gradient at that point, we need to evaluate it when x equals to 2, which gives us negative 1 plus 8. And to find the normal gradient, so we need to take the negative reciprocal. So something like that. Okay, and we have the point, we have the coordinate. And we can use this equation, the straight line equation, and we go through that point. Okay, we have our gradient 1 over 1 minus a. Okay, after you got it into this form, you can compare it with the equation where the question given you this form, right? Okay, so the negative 1 minus a, that will equate it to 4, which you get a equals to 5. And then the second part where b equals to a minus 1 to a plus 8 plus 2. You get a 4 times 18 plus 2. Yeah, 74. Okay, so you have your two answers. A is 5 and B is 74. And that concludes this paper. Thank you for watching. Hope you learned something. All the best.